Okay, so let's start with the new visualization, that is heat map. Now heat map is another visualization which is very useful and becoming very common now, because in most of the advertisements or presentations you would see that heat map is definitely a part of your presentation or ads, etc. So let's try and understand what is heat map. Now, a heat map is a data visualization technique that shows magnitude of a phenomenon as a color in two dimensions. The variation in color may be by hue or intensity, giving obvious visual cues to the reader about how the phenomenon is clustered or varies over space. Now, heat maps are everywhere these days. You see them on a weather, on real estate sites, basically anywhere you will see that there is a data to display. They are increasingly popular in scientific disciplines also, where large volumes of data have to be made comprehensible. That's because they have great way to see through data to trends and understand what to do next. Now, and while we may think of heat maps as a 21st century thing, it turns out that they have roots in the statistical analysis techniques of the 19th century. Now, heat maps are the most used tool for representing complex statistical data. Doctors, engineers, marketers, sociologists, and researchers of every kind use heat maps to make complex data sets comprehensible and actionable. That's the secret of their success. Charts have to be interpreted, tables have to be understood, but heat maps are self-explanatory, intuitive. So, what is heat map? A heat map provides a visual summary of information by the two-dimensional representation of data, in which values are represented by colors. So that is why you will see that the heat maps are always very colorful. These can be number of ways to display heat maps. But they all share one thing in common. They use colors to draw the relationship between data values that would be much harder to understand if represented in a sheet or a numerical values. Now, businesses or organizations can use as a means to describe their sales, customers' usage of products, websites, or financial data in a visual format instead of looking at a long, boring numerical sheet of data. That is the reason, and that is why it is becoming more and more popular. Heat maps can not only show the businesses what their current results look like geographically, but they can also spot opportunities. In the most simplified examples, what would you do as an online store owner if you know the areas where most of the visitors look at on your website? So you can, those kinds of finer things or minute things can also be displayed or presented in the heat map. Here are some of the solutions that heat map can offer. Enhancing marketing activities efficiency. Spotting underserved markets by seeing the cold and warm areas. Now, see, if an organization gets to know about these things, definitely they will focus and increase their efforts into those areas. Then, defining target customer segments by analyzing where the majority of customers reside and assessing regional demographics. Optimizing product tie-ups by understanding which products are selling in different regions. All these things are going to help the organization to improve their marketing strategy, to improve their marketing efforts, and definitely revenue is to increase the revenue. Benefits of heat maps: as heat maps are incredibly user friendly and can give new and useful perspective on the existing data, they can bring various benefits and opportunities for business driver. It fully exploited and utilized. There are 5 key benefits of heat map for businesses. That is, improving company-wide communication, understanding time-based trends, boosting sales funnel activity, creating competitive advantage, enhancing territory sales efficiency. And like that, many more can be added to this. An example of a heat map is data analysis software that uses color the way bar graph uses bright, height and width as a data visualization tool. If you are looking at a web page and you want to know which area gets the most attention, a heat map shows you in a visual way that's easy to assimilate and make decisions from that. What does a heat map show? A heat map uses a warm to cool color spectrum to show you your site analytics, namely which part of the page receives most attention. The heat map, for example, shows how far down the page visitors have scrolled. You can think of heat maps as a form of visual storytelling. Creating a heat map helps you understand visitor behavior instantly. They also help you answer a crucial question: where should the most important content be on this page? Now, these are some of the finer things which you can make out with the help of the heat map. Heat map is a way of representing data as a matrix of values. Basically, using different colors to represent data, it gives you a general view of the numerical data. Some manipulations when working with the heat map. Python heat map includes normalizing the metrics, performing user cluster analysis, choosing a color palette, and permuting rows and columns to place similar values nearby. Some simple Python heat map example. First, let's make a simple heat map to get an idea of what it is. Import seaborn as SN, import numpy as NP, import pandas as PD. Now these are, I think, familiar. So these are required for this. Then df data frame is equal to pd dot data frame, np, that is numpy, random 7, columns a b c d e f g, then sn heat map df. Simple heat map is being created here, and import matplotlib pyplot as plt. And when you write this, you have to, for execution you write plt dot show, and when you execute it you will get this kind of a heat map. Very simple, but definitely quite useful, quite meaningful. Like here also, the same thing is presented here in a different color, which is also possible with the help of this kind of a code. Now, annotation is very useful and very important. In Python or heat map, you can see that annotation is possible and it can be done. Let's see how. Now you can add an annotation to every cell of your Python. Now every cell means that the square that you are seeing, and you are seeing the number 0.23, 0.54, 0.39, like that it is mentioned. That comes with the help of the annotation, that is ANNOT. That is, when you write a code like sn.heatmap df, ANN that is annotation, is equal to true. It should be true. And annotation underscore KWS size is 7. That means this, you can also define the size of the cell. And when you write this plt dot show, you will see that a heat map like this will be presented to you. So here annotation KWS lets us set the size of the annotations. You see, the size of the annotation is also possible to mention there. With the size parameter, we set it at to 7 here. Now here we have mentioned it 7. You can change it depending on your requirement or whatever way you think is better. So this is the way you can create your heat map. Now adding grid, if suppose you want to further improve upon that, it is possible to add grid lines. Now grid, you can see between the two cells or two squares, you are seeing that there is a grid, that there is a division, so you can easily distinguish the two cells, right? And this is again a very helpful change. Like, it's possible to add grid lines to your Python heat map. In the following piece of code, we add pink grid. Now it is a pink grid, which you can see in between grid lines of the thickness 2.5. Now thickness also can be as per your requirement, so you can modify it this also, but here we are taking as 2.5. sn.heatmap df line width is equal to 2.5, and line color also you can decide, that is pink. Here we have taken, maybe you can say black or green or blue or whatever color, and then plt.show, so it will show that. So this is how you can create the heat map with a grid also. Now removing X or Y labels. in the next piece of code we remove the x-tick labels from the map. So how to do that? sn.heatmap df x-tick labels is equal to false. So when you say false, it will not be there. plt show, it is you can see that you can remove the color bar also, keeping only a few labels. Basically, when there are too many cells labels, there may be overlapping. So to avoid this, you can give a value x to the x-tick labels parameter. It then shows labels every x label. So this is how you can give it, like sn heatmap df x-tick labels is equal to 2 and then plt show. So this is the way you can keep on improving your heat map. Now this is here you can see that you can change the color of the heat map. Earlier we had multicolor, now we are having just a green base. So for doing that, let's try a green. Now sn.heatmap df.cmap. cmap means color map and the colors are greens. Green S, that means green shade. plt.show. So when you do that, you will get this kind of a color. You can further change the color and again make a multicolor type. Like let's try with the blue and purple. So sn heatmap df cmap is equal to bu means blue and pu means purple. So that is how you can change the color and plt.show. So you can again see the change of color. Then here again another change, that is yellow, green and blue. So you can say sn.heatmap df cmap is equal to yl, gn and bu. That is yl represents yellow, gn represents green, bu represents blue. So yellow, green and blue, that is a combination, and then plt.show will show you this kind of a heat map. Then red, yellow, blue is again possible with this kind of a combination, like sn.heatmap df.cmap is equal to rd yl bu, and again you can see that red, yellow and blue colors are mentioned in the heat map, right? Plotting a discrete heat map, here like this can also be done with the help of the this discrete heat map. Now for discrete data, you can choose a plot it with a Python heat map, normalizing a column. So consider the following piece of code, that is df_pd data frame np. np is of course numpy, random again 7,7, then multiplication 4 plus 3. So you can see that df1 is equal to df1 plus 37, and then heat map color map is plasma. So this is a combination, by default it takes that colors on its own, and then plt show. So you will get a color combination like this. Now in this plot, one has considerably higher values. To get around this, we normalize it, that is df norm, df, then df dot mean and oblique df dot std. sn heatmap df norm cmap plasma and plt show. So you can see that this kind of a color combination is going to appear for your heat map. Now there is another very useful facility available in heat map, is that is creating the word cloud in Python. A word cloud in Python, you must have seen these kinds of printing, maybe in sometimes magazines or sometimes in some other say printed matter, that the different kinds of words are presented in different colors and different fonts and different sizes. These are commonly being used these days. So word cloud in Python visually represents text data, also called a tag cloud. It uses different font sizes and colors to highlight the importance of each word. This way the most prominent term will come across to the user. Let us see how to use the word cloud library here. So let's see how to make use of that. Simple word cloud Python example, from word cloud import word cloud, right? Then text, Python, C, Java, JavaScript, all those things, whatever languages. Of course this you can change as per your requirement, but here for our understanding, let's keep it this way. Java, JavaScript, query, jQuery, R, Python, SQL, HTML, Lisp, Java, Ruby, jQuery, Python, then Python, Django, Scala, Python, JavaScript, jQuery. All these things, whatever you think it is required, or you can reduce or increase, whatever. Then word cloud is equal to word cloud, because you see, after all, you have to present it. So that is why as many words you want, it should be there. But then depending on the requirement, word cloud is equal to word cloud width is equal to 500, height is equal to this. Also you can define width, height, and margin is equal to 1, and generate text, right? So plt dot imshow word cloud interpolation is equal to bilinear. Now this, of course, you have to mention there. Then plt axis of plt margins is x equal to 0 and y is equal to 0, and plt show. So once you do this is just an example, it's not the outcome of this. So once you do this, you will see that it will be, a graph will be presented. Let's now try and understand that setting the font size. Now you can set a maximum and minimum font size for your word cloud. Word cloud width is equal to 500, height 500, max font size is equal to 30, minimum font size is 10, because both these things you have to define, and generate text. So plt imshow word cloud interpolation bilinear, and then when you go for plt show, you can say that you will get a graph like this, right? Then limit the number of words. Now that is again possible. Now let's see what happens if we don't call the axis and margins method. Word cloud, again the same code. Word cloud width is equal to 500, height 500, maximum words 4, margin is equal to 1, and then generate text. So now here number of words are kept as 4 only. That is why you are seeing only 4 words. And plt.imshow word cloud interpolation, and then bilinear, and plt.show. So you can see this kind of a graph will be appearing there. Then exclude some words. Now suppose you don't want all the words. So generally it is possible to use only some words from the text. Now word cloud is equal to word cloud width 500, again same dimensions. Stop words Java and Django. So Java and Django will not appear, right? Generate text. And plt imshow, so whatever you don't want, because you have created a string, and out of that you can keep on selecting, pick and choose what you want to present it and what you want to hide. All that is possible. So plt.imshow word cloud interpolation is equal to bilinear, and then plt.axis of plt margins x is equal to 0, y is equal to 0, and then plt show. So you can see that all those words which you don't want are excluded from this. Change the background. Now that is also possible. You can change the background. So you can set the background to a certain color. Word cloud, again the same code. Color is equal to dark turquoise, right? So you can change the color, whatever color you want. Depending on that, you can keep trying, and whatever looks fine, good, you can decide upon that. plt.imshow word cloud interpolation bilinear, again the same, and then fonts weight is equal to 400. Now you can also give the weight of the font, that means how strongly you want. Span, and then plt margin x0, y0, and plt show. So this is the way you can get this also. Then setting word color. Now suppose you want to change the color of the fonts. So word cloud is equal to, again word cloud height 500, width 500, background color is equal to white. You can change the color of the background, and color map is equal to plasma. The plasma color you have taken, and then generate text, and you can see that again the plt axis of plt show, and a word cloud of your choice has been created here. Then there is a shaping a word cloud. Now it's possible to set a Python word cloud for a custom shape. You can also create a shape. This shape is like diamond shape. Let's use a diamond. From PIL import image, mask is equal to np array image dot open diamond png, and word cloud is equal to word cloud generate text, and then plt imshow word cloud, and plt again axis within bracket of plt show. So when you execute this, you will see this kind of a output will be there. Then conclusion is that, so we have seen the utility and power of heat map. Also we have seen the ease at which these heat maps can be generated. Moreover, we discussed word cloud Python. In this, we saw that the word cloud and how to make word cloud. Also, we saw the word cloud Python example. So this is how we create heat maps and word clouds in Python. For this, we use the libraries matplotlib and word cloud, right? So this is the way you can create a beautiful, or as per your requirement, your heat maps and the word cloud map. Thank you.